Good day, everyone. You're welcome to chemistry class. The topic we want to consider today is empirical formula of compounds. Empirical formula of compounds. Now, we have the following objectives to discuss. At the end of this lesson, you should be able to define empirical formula of compounds. You should be able to identify and then do some calculations on empirical formula of compounds. So after this class, I expect you to be a master of empirical formula of compounds. Shouldn't have problem with it again. Now, to begin with, what is a compound? Can you pause the video and write down your answer? What is a compound? Some people define compound as a combination of two or more elements, and that definition is not good enough. If you are among those who that wrote it like that, that means you were not okay with that. You are not correct 100%. A compound is not a combination, it's not a process, it is a thing. Alright? So don't see a compound as a combination of two or more elements. A compound is a chemical substance formed when two or more elements chemically combine together, not physically combine together. If two or more elements physically combine together, what is formed is called alloy. Alloy, not compound. So an alloy is a mixture, but a compound is a pure substance. It's not a mixture. The element present in alloy just mix together, but the elements present in compound combine together. There is chemical bond between the elements present in a compound. So by definition, a compound is a chemical substance formed when two or more elements chemically combine together. That means they can only be separated using a chemical method, not physical method. Alright, using electrolysis in particular. Now, what do you mean by a binary compound? Have you heard of it before? Binary compound. The word binary simply means two. So what do you think a binary compound is? Pause and put down your answer. Alright. A binary compound simply means a compound that has only two different elements. A compound that contains only two elements. Can you name any compound that contains only two elements? Can you try that? Okay. Water is a good example. It has hydrogen and oxygen as the only two elements. Ammonia gas, sodium chloride, methane, butane, the gas used to cook at home, butane and propane. Alright, they are both binary compounds. So binary compound is a compound that contains only two elements. We have very many compounds that are binary compounds. That is by the way. Now let's move on to our discussion for the day. What is empirical formula? It is the formula that shows the simplest form of a compound. Alright, so empirical formula is the simplest formula of a compound. It shows the ratio of the atoms of each of the elements present in a compound. So empirical formula is the one that expresses the composition of a compound in the simplest ratio of the atoms present in that compound. For example, look at benzene with the formula C6H6. If you break it down to the simplest form, that means you are dividing by 6. So that C6 divided by 6 will give you C1. So H6 divided by 6 will also give you H1. And when it is 1, we don't normally write it. Therefore, the empirical formula of benzene C6H6 is actually CH. Are you okay with that? Now look at butene C4H8. What do you think we can use to divide it to bring it down to the smallest ratio? Alright, 4. So when you use 4 to divide C4, it will give you C1. And use 4 to divide H8 to give you H2. Therefore, the simplest ratio we can bring butene down to is CH2. So CH2 is the empirical formula of butene. Alright, look at butane, the gas you are using to cook at home. Now, if you use 4 to divide 10, that will give you 2.5. And when you are writing formula, we don't write point something, you write whole numbers. Therefore, the only way we can break it down to the simplest form is by dividing by 2 in this case. So that when you divide 4 by 2, it will give you C2, and then you divide 10 by 2, it will give you H5. Therefore, the empirical formula of butane is C2H5. I hope you understand that. So that is a simple way of breaking down a molecular formula, that is a formula of a compound, down to its empirical formula. Alright. How do we, let's consider the following. Let's identify the empirical formula of the following compounds. You are going to do this, put down your answers. Put down your answers. Now, it is possible for the empirical formula and the molecular formula to be the same thing if the empirical formula can never be further broken down to simpler ratio. Alright, so like the case of option D now, that is what you are going to see. So don't be surprised when you see molecular formula to be the same thing as the empirical formula of a compound. So pause the video and determine the empirical formula of the following compounds. Have you done that? Alright, pause the video and do that. Alright, let's look at the correct answers, whether you are right or not. Alright, for question A, the empirical formula is to be CH2, that is, you are dividing by 10. That will give you CH2 as the empirical formula. Now for glucose, which is C6H12O6, you are dividing by 6. So that will give you C1H2O1. So that is why we have CH2O as the empirical formula of glucose. Then for option C, you are dividing by 2. So that the empirical formula becomes C1H2O1. Then for option D, the empirical formula, already you can see one of the atoms at the smallest level, that is having one atom only. So that is the simplest ratio you can break it down to. I told you cannot have in form of decimals. The atoms are always in whole numbers, not in decimal forms. Therefore, for option D, the molecular formula is the same thing as the empirical formula. Then for E, you divide through by 2, so that will give you C1H3. So if you have gotten it right, that is a good one. That is 5 good marks in your pocket. Alright, how do we calculate empirical formula from a question given to you, from analysis given to you? Now, the first step to solve problems on empirical formula is to write down the elements present in the compound. You must be able to identify all the elements present in a particular compound given to you in a question, and then the mass numbers, the masses of each of the elements given to you, or the percentage of each of the elements given to you, you should be able to identify it and write it down. So the first step is to divide the masses given to you by the mass number of each of the elements in the question. Don't worry, we are going to solve some of them. You see how it is, they are solved. Now, the second step, after getting the moles, how do we get moles? The first step will give you the moles. Mass over molar mass. You know, that is the formula used to calculate mole. So the mass given to you over the atomic masses of each of the elements will give you the moles. And then in step 2, you look at all the moles you obtain from each of the elements, and then you divide through by the smallest mole that you obtained in step 1. Then the last stage is to write out the answers you got from step 2. And then if in case the moles you obtained are not whole numbers, maybe you get something like 2.5 in one of the atoms, that is, you need to multiply everything by 2 so that you can have whole number. However, if you get something like 2.9, then you are free to approximate that to 3. Alright, please don't forget this. This is very, very important. Okay, now let's consider some examples, some calculations on empirical formula. Example 1 says, find the empirical formula of a compound which yielded 2 grams of carbon, 0.34 grams of hydrogen, and 2.67 grams of oxygen. We have to determine the empirical formula of the compound. Now, they will always give you the mass numbers of each of the elements present in that compound that you are analyzing. Alright, this is the way you solve it. The first step is to write out all the elements present. From the question, we have carbon, hydrogen, and oxygen. So, what is the mass of carbon given to you in the question? It's 2 grams. So, you divide that 2 grams by the mass number, which is 12. Then the mass of hydrogen given to you in the question is 0.34 grams. So, you divide that by the mass number of hydrogen, which is 1. Then for oxygen, the mass of oxygen given in the question is 2.67 grams. Then you divide that by the mass number of oxygen, which is 16. When you do that, 2 divided by 12 will give you 0.17. Then 0.34 divided by 1 will give you 0.34. And then 2.67 divided by 16 will give you 0.17. So what you actually have is going to be 0.17, 0.34, then 0.17. Among these three values, the smallest value we have is 0.17. Alright, therefore you divide through by 0.17, which is the smallest mole. And when you do that, you are going to get 1 for carbon, 2 for hydrogen, then 1 for oxygen. Therefore, the empirical formula is going to be written as C1H2, then O, oxygen 1. But we don't normally write 1 in formulas. Therefore, the empirical formula of that compound that was analyzed is CH2O. Please pause it if you don't understand. Listen to it again. Alright. Now, let's see whether you understand what I've explained to you. Do this work for me. Pause and do it. Calculate the hydrocarbon. Alright, I think this is having a problem. Supposed to calculate the empirical formula of the hydrocarbon containing 92.31% carbon and 7.69% hydrogen by mass. Alright, should be calculate empirical formula. Okay, now what is hydrocarbon? That is where you begin with. Hydrocarbon is a compound that contains carbon and hydrogen atoms only. A compound that contains carbon and hydrogen atoms only, like benzene, C6H6, like butane, C4H10. Any compound that contains carbon and hydrogen atoms only is called hydrocarbon. So, we have been given a question like this. Go ahead and solve it. Let's see your answer, if you can determine the empirical formula. Alright, the answer to that question is CH. How do we do it? Let's go through to see whether you got it right. The elements present in the compound are carbon and hydrogen. Percentage of carbon is given to be 92.31. Therefore, you divide by the mass number of carbon, which is 12. The percentage of hydrogen is given to be 7.69 divided by the mass number, which is 1. Now, get this clearly. Whether they give you the percentage of the elements or they give you the masses of the element, is the same procedure. Just go ahead. First step, divide by the mass numbers. Second step, divide by the smallest mole. Okay, so that is how you go about it. So in this case, we have for carbon, 92.31 divided by 12 will give us 7.69. Then the same thing, 7.69 for hydrogen divided by 1 will give us the same value. So you see that we have the same number of moles. 7.69 for carbon, 7.69 for hydrogen. Therefore, you divide by 7.69, and that will give you the answer to be ratio 1 to 1. Can you see that? So that is how we get the answer to be CH as the empirical formula of the hydrocarbon that have 92.31% of carbon and 7.69% of hydrogen. Are we okay with that? Alright, this is very, very important. Let's look at example 2. Very important. Now, I have shown you how it is solved. A sample of hydrocarbon burns in excess oxygen to yield 8.8 grams of CO2 and 5.4 grams of water. Determine the empirical formula of the compound. Now, in this case, they didn't give you the mass of carbon, they didn't give you the mass of hydrogen directly, but they have told us it is hydrocarbon. So automatically, the elements present there are carbon and hydrogen. Now, to get the mass of carbon from the CO2 they have given you, you look at the molar mass of CO2, which is obtained by adding up the masses of carbon and oxygen. So that will give us a total of 44 gram per mole. Now, the contribution of carbon out of the 8.8 gram of CO2 will be obtained by doing this simple operation. That will be 12, which is the mass contributed by carbon, over the total, which is 44, times 8.8 gram, and that gave us 2.4 gram of carbon. Then you do the same thing for hydrogen in water. The molar mass of water is 18 gram per mole. Mass of hydrogen in that 5.4 gram of water will be 2 gram, which is contributed by hydrogen, over the total 18, then multiplied by 5.4 gram, and that gave us 0.6 gram of hydrogen from that compound. Now you go ahead and you carry out the operation I've told you before. Carbon mass we obtain is 2.4 gram, then you divide by 12, which is the mass number of carbon, that will give 0.2. Then the mass of hydrogen obtained is 0.6, divided by the mass number of hydrogen, which is 1, and that will give 0.3. So the moles we have in is 0.2, 0.6. So you divide by 0.2, and that will give us the ratio 1 to 3 for carbon to hydrogen. Therefore, the empirical formula of the compound analyzed in this case is CH3. Please, if you don't understand, pause it again and listen to what I've explained. In summary, empirical formula shows the smallest ratio of the atoms present in a compound. How do we obtain it? By dividing the number of atoms in a compound by a number, a particular number that can bring the atoms down to the smallest ratio. And then in a particular analysis, in a question, you can also obtain the empirical formula by finding the mole, then divide through by the smallest mole. So that is the summary of our discussion. Now you have the following questions to solve. Solve them and see whether you understand what I've explained to you or not. You can put your comments in the comments box so that I can see your opinion over what we have discussed so far. Right. Thanks for listening. God bless you.